Hello everyone, this is L. Suresh Kumar from CPWD. We are at Anna Nagar, Chennai, and here this particular site is a monolithic concrete technology site, and here what we use is tunnel form technology, and we will start from here. So this is our customs project. So we are at foundation level, we call it F1 level. F1 level slab is casted, and those towers, whatever you see there, those are income tax towers which are nearing final. This is now this is F1 slab. We are using, as I said already, it's a tunnel form project where the predominant load distribution is by walls and slabs. So there is no columns or beams. So predominantly the load distribution is by box behavior, shutter box. So eventually we need boxes to create those structures. Those boxes are tunnel form boxes. Those are imported from Turkey. Mesa is a manufacturer. So this is that tunnel form box. This is a inverted U. So the base is previously casted concrete. The top is inverted U shape. The inverted U shape is formed with two L frames, two half tunnels we call it. Two half tunnels connected together forms an inverted U, and like this, when many U's are placed, in between there will be a cellular gap can be left. So that forms the wall gap, and the top which is getting connected will automatically form the shutter for the top slab. So the entire tunnel can be casted in one go, meaning the wall as well as the slab can be casted together. So that is where this tunnel form technology becomes a monolithic concrete construction methodology. How this tunnel is horizontally on grounds, how it will be moved. Okay. So this is a hydra where it is connected to the exact CG point of the tunnel. So if you see, this is the entire half tunnel which is hung at one single point. This is the point where it is hung. And the CG point is so balanced that the shutter form will be always hanging vertical. The CG point will be shifted and the point will be located in such a way that the entire box will be hanging vertical. And these are horizontal valves, and these are the side panel, top panel, and that is end panel. So these kind of two half tunnels will be placed together to form one room or one cellular space. This is particularly called as outer frame, or which has to cover the outer walls, and this will be actually loading on the outer cantilever platform, a needle platform which will be hanging from the below floor. We are in the ground floor, so we have made temporary arrangements. If you raise further, there will be a suspended platform from the wall itself, over which this will be resting. Not on the concrete. This particular external wall panels will not be resting on the slabs. It will be hanging outside, and so once when the outer panels are de-shuttered, so what is need to be done is, here we are using external coating or curing compounds. The reason for using curing compound is to avoid excess usage of water. We can save a lot of water here. Here it is a very high humid region at Chennai, so curing compound really works. A proper coating of curing compound in high humid regions will work. In low humid region there will be a very high suction pressure which will be there. So there curing compound has to be investigated and then properly used. Now we are on top of the tunnel form casted slab. So we casted just 2 days before, 48 hours before. We already de-shuttered on 36 hours. If you can see the tunnel, there is a difference. We have already started de-shuttering. So the main advantage of this tunnel system is that we will be able to do 1 week, 1 floor, whatever may be the size of the building. So 1 week, 1 floor is possible. In a month, 4 floors is really practically possible in Indian conditions, and further it can be improved when things become very fluent. So even 1 day, 1 floor being achieved in Western countries. We have already planned for the next pour. The wall reinforcements we have already started. We have casted, and on the very next day, after 24 hours, even still curing is going on. So only the top surface where curing compound may not work because of the labor movement and some material movement on top, we are not using curing compound. We generally go for moist curing, and we have started our next floor activity, which is tying of vertical reinforcements. You can see these reinforcements. These are behavior is the wall behavior, and these are boundary elements. Proper ductile detailing is being followed, and now in another maybe within one day, this entire four quarters forms one set of tunnel. The entire wall reinforcement will be over. Within another few hours, the service elements like electrical and fire related conduits will be placed. Then afterward, it is ready for placement of tunnel. When the tunnels are placed, and again the slab reinforcement has to happen. When the slab reinforcement is done, it is ready for concreting. Now I just want to explain how geometrically stable the tunnel form is. Now you can look at this particular wall. All interior walls are 160 mm thick. You can see that 18 floors, that 160 mm wall literally goes perfectly aligned. And what is the idea and method of achieving this 160 mm wall without any eccentricity? So as I said you, this particular element really creates perfect alignment of the structure. So this actually automatically creates. So if you can see this particular corner goes on top of the tunnel, that is L box frame. It goes and gets locked here. So the space between these two is the wall thickness. In my case, it is 160 mm, and this particular thickness is the slab thickness. Okay, this is slab thickness, and of course, yes, this will form a very small hole there in the slab. After removal of the shutter, these holes are to be filled. Why this particular arrangement is required? So that this two lines is parallel to these two lines, and we form a kicker here, or in a normal column case, we provide starters. Like this, a starter will be placed here. So when you pour concrete, this is the slab thickness, plus there will be a L frame running like this. So we will pour concrete here. This will form a perfect image of the below wall without any eccentricity.